Okay, I'm going to look at practice problem 2 right here, where we have to actually calculate the absolute pressure inside a cylinder. All right, so start this problem, zoom in. Okay, back. Okay, so first part of the problem, we're looking for the absolute pressure. So pressure absolute. We're given some quantities from the problem. We have the force, it's given 1.20 kNewtons, and the radius. And of course, the atmospheric pressure, right? Now, one of the things we have to do, what we recognize is pressure when we're talking about Pascal. Pascal is just a Newton per meter. So we're going to have to be in units of newtons and meters. Or in this case, we could also work with k-newtons. So first thing you need to do is make the conversion between centimeters to meters. If we do that, just we use the conversion factor 1 meter over is equal to 100 centimeters. And when we multiply that, we come up with 3.25 times 10 to the minus 2 meters. So in this problem, they gave an atmospheric pressure of 100 K pascals, or 100,000 pascals. Okay, so for governing equations, absolute value is what we're calculating, so that's what we need to find. So we're going to find the gauge pressure and add it to the atmospheric pressure to come up with the absolute value. Well, the second part of this is how do we figure out pressure? Well, inside of a cylinder, it's just going to be the force divided by of the piston, pushing down on the piston, divided by the cross-sectional area. Okay, and of course, how do we come up with a cross-sectional area of the surface of a piston? It's just going to be area of a circle, which is pi times the radius squared. And one other thing we'll need is that the conversion for Pascal to newtons per meter. Okay. Okay. All right. Second part of the problem, the approach we're going to take. So first part of this, we're going to calculate the area because we want to calculate the pressure, the atmospheric, the gauge pressure. And so the area, just going through the calculation, we come up with just 3.1415 times 3.25 times 10 to the minus 2 meters and square that. And here is our area of that surface of the piston. Okay. Then we use that, and I convert it over to newtons, and newtons per meter squared. This is actually, I made a little mistake here. This should be squared, so make sure you got meters squared here. And that's actually becomes 362 K pascals. Okay, so Newton per meter squared. And I forgot that right here. It should be Newton per meter squared. Okay. Okay, so then we've got that. That's our gauge pressure. It's going to be 362. So now what we do is we use that, the gauge pressure plus the atmospheric pressure. We add those two together, and we come up with an absolute pressure of 462 K pascals. And that is that problem.